In this lesson I will go through parallax mapping, which is a technique that gives you fake height and depth on a single texture using only one plane. So we start right away by adding a texture coordinate. So Shift A, input texture coordinate, so select that one. We also need a geometry node, so Shift A, input geometry, and that is used to catch the viewport camera, which we get from the incoming here. So we need a texture, of course, so Shift A, texture, image texture, put that in, and texture inside this node, so open, and in your resources select par color, and just connect the color to the base color and go to render view so you can see how it looks. So this is a normal texture, no strange things at all. What happens if we connect it to the incoming? Let's try. So incoming to the vector, and now it moves around like this. So if we look at it, it looks almost like we are looking into some depth here. But the strange thing here is that we get not a flat image that is a bit low or something like that. No, we get like a wall on the sides. So it's almost like a ball and not a flat image. And we would like this image to be flat, but further away from this plane. So we need to fake that, and the reason that it looks like a ball is that we don't have an information on this plane with depth. We only have x and y. There is no depth in here, but we are trying to give depth using the incoming to this plane. So we give additional information that this plane can't handle. So we must take that away, and there's a simple way to do it, and I can do it right now by adding or separating, so I get the depth and then just divide that depth with the x and y, so I only have the x and y left, but that it has gone down or up a bit according to what we have as a depth. It's much more easy than it sounds. So we start with just Shift A and go to Converter and find Separate XYZ. Put that in here and take the incoming here. All we have to do now really is to take the Z and divide it with the information that we get here. So Shift A, Converter, Vector Math, put that in, change this to divide, and use the Z, which is the depth, into the vector here. And now you can see that it looks like a plane all the time. It's not distorted. It gets a little bit smaller when I have it like this. It gets a little bit bigger when it's like this, because now when we look straight at it, it's of course a little bit shorter way to the camera than we have if I look at like this, because then this will be longer way to travel from our viewport to this end here. But everything looks okay now. It really looks like we are looking at the texture. So it solved that problem. The next thing I would like to do is be able to raise it up or lower it a bit. And that we can do by multiplying the incoming value, so we get it higher or lower. And you can do that very easy by using scale, because scale is the same as multiplying, but we don't need to multiply 3 times, one for each axis. We just change it with one scalar number. So Shift A, and then we go Converter, Vector Math, put that in here and change it to scale. And now you can see that if I now change this scale, you can get it to be further away or closer here. So it's really convenient to work with this in a good way. So here we have it, and what we can show now is that it really looks like we have 2 layers. So if I take this texture as well, so Shift D, just copy it and put that to the UV and put in a mix between these two. So Shift A, converter, no, sorry, color and mix RGB. We put that in here. So we have two. And I then move around here, can take down the scale a bit, like that. Then it looks like you have a thin ice layer or something at the top, and then you have a few meters below the ground moving around. And that is how Parallax mapping is working, but we are missing a few steps because now we have like a top layer that is where we have our UV, and then we have a bottom layer that is then scaled with this scale here, which means that we have then made it go lower down. And what we should need is that we should have one value for each value up to we have scale 1 or 2 scale, so they are matching like in height. So we need to fix that in some way. So normally you go through a long range of images by using a loop. So that is something we don't have in Blender. So we need to solve this in another way. And that is a cheap way to cheat. So I will do that for you. I will take away the top image here by pressing delete and take away the mix. And just put this in straight into the color like this. So now we only have one image in. But before I continue, we also need different types of height or scale, because these stones or rocks doesn't have the same height as the ground. The ground is a bit lower than the rocks here. And to control that, we need something called height map, which is almost the same as a bump map, which means that if I have a bright color, then it's high up, and if I have a dark or black, then it's a bit lower. So by using a height map, we can then control everything here. So I add a height map. So Shift A, texture, image texture, and I put in our resources, I find something called par height. So par height, put that in. And then we could use this to our scale here, but it doesn't look so good. Because what we're doing now is more or less making a texture bigger or smaller according to what we have in the height. But what we would like to do is to change the location of the UV. So to do it in a correct way, we need to have a mapping node here. So I press Shift A, and then I go to vector, and in vector I find mapping, and I select that one. So I put that in, and I put this on the location instead, and I put UV on the vector. So I take our texture coordinate and I drag the UV to the vector here. And now we have something else. It still doesn't look so good, but it is not that distorted that it was before. And that is because we need to change a few things here. The scale is rather high, so we take that down a bit. It's also so that we would like white color to be positive and a darker color to be negative. So to change all those things, the easiest way is to add a map range here. So I press Shift A, go to converter and map range, and put that in. And then if I now change this to a small negative number, so we put this to 0.1 perhaps, and to max, then we take that down as well to 0.1, like that. And now you can see it's getting higher on those parts and it gets lower on the other parts, but it's still a bit too much. So we really need small values here, and it's hard to change these in a good way. So we add some more math here and an input value. So Shift A, input and value. So we just can put in what we want here. And then we divide it by 100, so it gets really small. So Shift A, and then you go converter and math. Divide it by 100. And then you put in the value here, and we put that to the max value here. And now it already looks better here, because we're using a smaller value. But we do the same with the minimum value. But to have it negative, we multiply with the negative number. So I press Shift D to copy this one, change it to multiply, change the value to -1, and put the information from divide to the top, like this, and put this to the minimum value. So we have it in. And suddenly you can see that this really looks good. And of course, if you then change the scale here, you really got the information working in a good way. So depending on what you're looking at, you can see that it looks rather good. So it could be that now you see some distortion here. You can minimize that also a bit by changing this into stepped linear, and then you get all those layers I was talking about. You can get, in this case, 4 layers. If you change it to 10, you get 10 layers, and so on. So you don't get the distortion, but you get visible layers. So you would need to find like a good between number here. So you can put in like 40 or 50 or something like that. And then you have distortion in some cases, but not so much. If you look from the top here, it looks okay, and it looks rather okay from this angle as well. Then on some other angles it looks a little bit, yeah, not so good. But you get the height and you get the depth by using this cheap way. And with a normal map, because you can use exactly the same information that you get from this, with the normal map together with the color, you can get a really nice result. So let's add a normal map as well. So Shift A, texture, image texture, and we open our normal. Put that in, put in a normal map between here. So Shift A, go to a vector, normal map, set the color to the color change. So we are using color space non-color, and put that to the normal here. And now it really looks good, but it will look even better when we take this information and put it in here. So now we have the mapping node that goes to both of these. So if you look in the wrong direction, because normal maps are built so one direction works better in another direction, it looks not so good, but if you put it in the correct direction, it looks really good. So now we have all the puzzle pieces in here, and you can simply change this. You can see now that the ground is growing or shrinking depending on the value you put in. And you don't have to go high, because as I said before, we are working with small values here, because the information we get from the camera and the incoming when it comes to the shutter depth is, it's rather small. So if you work with high numbers, it will only be like stretch here. Of course, it depends on what type of texture you're using and what type of height map you're using. But often it will be something about 2, 3 perhaps, not more, to make it look really good. So with one single texture and also together with the normal map, you can get this to look really good, even if you are like in a rather narrow angle. You can't go too much, because then you can of course see the layer here and everything gets flat and so on. But already here you can see the layers then connect with each other, and you get this image here where everything looks really okay, and then it's just to tweak the values here. So this is without any height. This is what normal map is doing. So you get some fake from the normal map, of course. That is what the normal map is used for. But it still looks a little bit flat here. But if I take up this, you can see now that you get this height here in a good way. And that is all there is to it. So this is how everything is working, and hopefully you have learned something in this tutorial as well, and I see you in the next lesson. So I just say bye for now.